Hi and welcome. In this video, you're going to learn how to explore and describe the relationship between two quantitative variables. This is the first part of a series of videos where we're going to learn about the form and direction of the relationship. And in the follow-up video, we're going to learn about the correlation coefficient, which is a measure to describe the strength of a linear relationship. Let's start with looking at a data set that involves two quantitative variables. I'm going to go to textbook chapter 3, which is all about describing the relationship between two variables, but we are interested in quantitative variables. So let me scroll to an example that includes quantitative variables. I'm going to find it right here. This is an example about the worldwide internet and Facebook use. What this data set is or consists of are measures on 32 countries. Argentina, Australia, Belgium, Brazil, Canada, and so forth. And what we measure for each country is its internet penetration. And what is meant by that is the percent of the population that has access to the internet. And the second variable, the second quantitative variable, is Facebook penetration, the percent of the country's population that uses Facebook. So if you look, for instance, at Belgium, Belgium has an internet penetration of 82%. 82% of its population have internet access, and Facebook penetration is 44%. This is how the percent of the population that uses Facebook. Now, if these Facebook penetration numbers seem kind of low, this is because this data set is from 2012. So it's quite old, and I'm sure these numbers have changed since then. How do we describe or explore the relationship between these two quantitative variables, internet penetration and Facebook penetration? We start with constructing a scatter plot that shows their relationships, their relationship. So I'm going to switch over to the artofstat.com webpage, and I'm going to go to the Scatterplots and Correlation app, which lets us construct an interactive scatter plot. So I'm opening up a browser window. I will go to artofstat.com and then click on web apps right here. This will bring me to the web apps of the website, and then I'm going to scroll down to the group that's called group of apps that's called association, correlation, and regression. And here is the Scatterplots and Correlation app that we're going to use today. So I'll click on that app to open it. And by default, the data set I just showed you will be displayed. It's called the Internet and Facebook data set right here. It shows the internet use plotted on the x-axis and the Facebook use or Facebook penetration plotted on the y-axis. Why? Because internet use plays the role of the explanatory variable and Facebook use the role of the response variable. We want to investigate how Facebook use depends on or is explained by internet use, and not the other way around. So internet use as explanatory variable goes on the x-axis. Remember, explanatory variable x-axis, the x in both words. The first, first, each point in the scatter plot represents a different country. We can actually see the coordinates by hovering over a point. So this point here refers to Japan, which has an internet use of 79% and a Facebook use of just 14% in 2012. Other countries are Spain. This one is Sweden. The United States should be around here. Here's Australia. The United States is here with an internet use of 81% and Facebook use of 52%. And India is down here with only 13% internet use and 5% Facebook use. The first thing to look for in a scatter plot is the form of the relationship. What form is the relationship of? And here we loosely distinguish between three scenarios. The form is either approximately linear, it's not linear, or there's really no relationship. This scatter plot here shows an approximately linear relationship. This is easier to see if we include, by clicking on the smooth trend option here, a smooth trend line that tries to capture the trend between the two variables. And as you can see, that trend seems to be pretty linear because that smooth line looks almost like a straight line. In fact, we can overlay a straight line, a linear trend line as well, and you'll see they look almost the same. So with the help of this line, it's perhaps easier to see that there is an approximate linear relationship between internet use and Facebook use. Why approximate linear? Because the dots here, the different countries, they tend to cluster around that line. The second thing you want to describe is the direction of the relationship. And this is just looking at what happens as the explanatory variable increases. What happens as internet use increases, Facebook use increases as well. We call this a positive relationship. So there's a positive, approximately linear relationship between internet use and Facebook use of countries. I'm going to quickly show you an example of a negative relationship. The gas mileage and weight data set here plots the weight of a car in kilograms against the miles per gallon, how fuel efficient it is. And here we see a clear example of a negative relationship. If I remove that trend line, it might not be as obvious, but notice or the picture might be distorted by this one observation here, the Hummer, which is a really heavy car, about 6.5 tons, but very not fuel efficient at all. So if we actually remove that point, which I can click on this option here, I can remove that one, just drag it out of the picture. You might see a stronger linear trend. If you do the smooth trend, for instance, this looks approximately linear. And so this also is an approximate linear relationship, but it is now a negative relationship. The heavier a car, the lower its gas mileage tends to be. Let me show you a picture of two variables that do not have much of a relationship at all. The Tour de France data set, for instance, plots, let me remove the linear trend here, plots a standardized performance measure on the x-axis. And this is just a combination of the timed trial and the overall finishing time. And all you need to know is that lower means better or faster, and higher means slower. And the attractiveness of the rider taking part in the Tour de France. So the performance of a rider plotted against the attractiveness of the rider. I think this was measured on some scale, and it's an average of a couple of measures. Now this shows more of a cloud of dots, and there doesn't seem to be much of a relationship. So this is almost no relationship. Although if we do include a smooth trend line, it's pretty flat, although there's a slight negative trend that you will also see when you include the trend line. Finally, let me show you a picture of not a linear relationship. This very last example about fuel efficiency plots a steady, this is data from an experiment that plots the steady, excuse me, plots the steady driving speed on the x-axis, at 5 miles per hour, 10 miles per hour, and so forth. And at each of these conditions, at each of these driving speeds, the fuel efficiency was measured. This scatter plot shows a clear non-linear relationship. Initially, as steady driving speed increases, think of it as you're driving at 10 miles per hour or 15 or 20 miles per hour, the fuel efficiency increases. But then as you hit the sweet spot at roughly 40 or 50 miles per hour, but then the fuel efficiency continually decreases as the steady driving speed increases. Like if you're going on the highway with 60 miles per hour or even 70 miles per hour, you're much less fuel efficient than if you're driving with 50 miles per hour. So this is a clear non-linear relationship. And if you overlay the smooth trend, this is clearly visible. All right, so we use the Scatterplots and Correlation app to make a scatter plot, to hover over points to see what countries or cars they refer to, and to judge the two things about the relationship. Its form, is it approximately linear? Is it not linear, or is there no relationship? And its direction, which we described as either positive or negative. A second video will explore the correlation coefficient that will determine the strength of an approximate linear relationship.